So from yesterday, can somebody put in their own words what it means when we divide a polynomial by a monomial? What does that mean? But what do you do with that? Like we did yesterday. Keep going. You make it into its own monomial, right? So each one, if 3 cubed and negative 6 cubed both share a 3, they can both have the 3 individually, right? That's what we looked at yesterday. I believe we did this problem and this problem. Did we do these two? We did. No, we didn't. Let's do example number 3. So instead of writing it all out like this one, where I have to write it all out, whenever you see some type of polynomial being divided by just one, just a monomial, all you have to do is just give each one of these terms that denominator. So let's do that. 3x squared divided by what? 3x. Minus 15x divided by what? 3x. Then all you have to do, hold on. All right, so now we can just factor these individually. So I'm going to factor that out, what's left? Just an x. And up here, these go away, and when I cross off the 3, what's left over? 5. But I think this is too messy. On the next one, I think I'll factor as I go. So this is just x minus 5. Yes. We did. Okay, well, let's just look at them again really quick. Thank you, though. So we have 4p squared. Oh, I want to change my color. 4p squared, but I'm going to factor it as I go. Divided by what? 2 times p. Minus, I'm going to say 9 times 2 times p. I just think it's a lot neater like this. Then you don't forget anything, because this way you can possibly forget something. If you do it, just take that little extra step. It can mean the difference between getting it right or getting it wrong on a text, right? So the 2's cancel, the p's cancel. 2's cancel, p cancels. And what's left over? 2p minus 9. Okay. Oh, we did already. I was thinking we were on this page. Sorry about that, guys. Okay, so let's do these. 2y squared, so how am I going to write that? 2 times y all over 3y minus 3y over 3y minus 9 over, I want to factor that, 3 times 3 over 3y. Yes. 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 So this, well, the way we used to, let me finish it and then we'll look at how we used to do it, okay? So these cancel, all of this cancels, and all of that cancels. What's left over? 2y divided by 3 minus 3 divided by y. The other way we used to do it put that over here. Bless you. The other way we used to do it was 2y squared minus 3y minus 9, all divided by 3y. But see, we can't factor anything out. I guess we could factor it this way. Is this factorable? Let's see. Do two numbers make negative 18 but add up to make negative 3? So I would put 2y squared here, negative 9 here, negative 6y, positive 3y, and this would be 2y times y, negative 3, and 3. So this would be y minus 3 and 2y minus 3. Thank you. Plus 3, all over 3y. Did that help us out at all? Can we do anything? Can't do anything with it. No, this is, I mean, back when we used to do this, this was all you could do, right? There's no way to divide it. We're not going to do that. Well, do you see why we have to learn this by now? You can't divide this. There's no way to simplify it. Yeah, so since we can't divide it, we have another way of doing it. It's just like adding tools to your tool belt. So since we can't do anything with that, we can say, oh, but I can divide each term by 3y. I can say 2y squared divided by, you know, each one of them, and then I could start to simplify it. So let's do this one. N squared divided by, sorry, yeah. Uh-huh. These? Because there's a negative sign right there. You can only do that when you're multiplying. Or when you're equaling. Yes, if this was an equal sign, you still wouldn't be able to do it here because that would make it unequal, right? But if there's an equal sign and there was a 3 down here, we could cross both 3's off, right? But you can't cross it off that way because that's unequal. Okay, moving on. So n times n over 5n plus 5 times 2 times n over 5n plus, I'm not going to factor 12. Why am I not going to factor 12? Why didn't I factor 12? Because there's no reason to. It's not going to cancel anything if I do. And let's erase all of this. And we'll write over here. Can't be, I like Vanessa's question. It's a smart question. Can't be simplified. Because it does explain why we have multiple ways of doing this kind of stuff, right? All right, so let's cancel. Cancel. 5 cancel. And that's it, right?
Yeah.
The n, thank you. So this equals n divided by 5 plus 2 plus 12 over 5n. And we don't have the same denominators with any of them, so we can't do anything else. All right, let's talk about this. Pencils down. So now we're going to go one step further. We're going to divide by a binomial. Makes it a little more complicated, right? So we have another way of doing this. And actually, you guys already know how to do this. You just don't know it. Can somebody, by just looking at this, tell me what the answer is? That's x plus 2. Good. You guys are smart. Okay. We'll explain why that works in just a second. Okay, so this times this is what? X times x. Oh, wait. We don't want to do that. It says x squared plus 3x plus 2. So I put that inside here. Here's a really silly way of putting it, but it's the first one who comes home gets to park in the garage. Who's heard that before? Okay, so x squared plus 3x plus 2 goes inside the garage. X plus 1 goes outside. Correct? So, in order to find what number times what number makes this, I have to, what? Just like this, guys. Eight times what makes 40?
5.
X times what makes x squared? X times what makes x? And 1. So the answer to this is x plus 2. Right? Or, like everybody else was doing that was shouting out their answers, to factor this, it would be x plus 1, x plus 2 divided by x plus 1, and these cancel. My answer is x plus 2. The reason you can't do that with everything is sometimes things aren't factorable, right? So that's why we have this method here. I'm showing you how to do it with easy ones that you could normally factor. Somebody asked me in the last class, but why can't we just do that? Well, you could, but you need to practice the easy ones so that when we have the ones that aren't factorable, so you can do those. Okay? All right, so let's look at the long division way instead of the conceptual way. So let's go back to, okay, so 984. Where does 984 go? Inside. And 3 goes on the outside. 3 times what makes 9?
3.
Draw the line, change the sign. 9 minus 9 is 0. And now what do? Bring down the 8. 3 times what makes 8? 6. Draw the line, change the sign. What do I do now? Bring down the 4. 3 times what makes 24? 8. 8 times 3 is 24. Draw the line, change the sign. 0. We have no remainders. I'm going to do the exact same process with this. X goes into x squared how many times? X times. I'm going to put x above here because it matches with that one. It lines up. X times 1 is x. X times x is x squared. Draw the line, change the sign. X squared minus x squared is nothing. 3x minus x is, what do I do now? Bring down the 2. X goes into 2x how many times? 2 times 1 is 2. 2 times x is 2x. Draw the line, change the sign. That's the most important part on these. That's where most people make their error, is they don't change the sign. And my remainder is 0. All right, so let's do these together. I think I'll stop it there and let you guys do these.